Welcome, everyone. If you are new to the channel, welcome. If you are returning, welcome back. The entirety of Chemsketch could not be explored in a single video. So here we are. Going to show you guys Chemsketch again. I'm just going to wait a little bit for the room to kind of fill in, get a couple of folks in here. So if you're watching this as a recording, then there will be a pinned comment with a timestamp that shows you the time that the actual tutorial starts. So click on that link and it'll take you on a quantum leap to the beginning of the actual Chemsketch tutorial part of the show. So let's see how many people we got in here. Let's see. I don't even know where I would find that. Hey, we got a message in the chat from Akalesh. Says hi. Hi back. Thank you for joining. Just going to wait for the room to fill in. By the way, this stream is brought to you by boredom. I'm bored. I'm not used to being bored, you know? But my family's out of town, so they'll be back in a couple of weeks. But in the meantime, I don't have much to do. When they are in town, I am never bored. There's never an idle moment. The kids keep me occupied, but I'm bored. So here we go. Now we're streaming. So hopefully I've changed a couple of things in the stream. First of all, I'm much closer to the microphone. I was watching that previous recording and it didn't really sound good because my face was kind of all over the place. Wasn't speaking into the mic the whole time. So here we are speaking into the mic. I also turned my mic up a little bit. So hopefully it sounds better. Let me know in the chat how the audio sounds and I can adjust it or not accordingly. Hello, hello. All right. So let's get into it, shall we? Akalesh says, yes, it is way better. Oh, so that implies that you were here before or you watched the recording. Thank you very much for your support, man. Appreciate it. All right. So enough about me and my boredom. Let's get right into playing with Chemsketch. So as we can see, got it open. And just a reminder, the whole point of me showing you this is to help you expand your understanding of organic chemistry, mainly. I mean, it helps with general chemistry too, but it really helps with organic chemistry. Playing with this software can really help things click into your mind. And also, as I said in the previous stream, you can copy and paste whatever images you make in this software into a word processor like Microsoft Word. And that can help you make some really sharp looking lab reports. You will blow your lab instructor away. You will stand out from your peers and your lab instructor will be impressed. You'll be able to hit him up or her for a letter of recommendation later on and get where you want to go in life. All right. So one thing that I kind of left out in the previous stream is a feature that I think is really useful. So imagine that we want to, let's draw a molecule. So I've selected the chain tool here. So let's say I want to draw bromopropane, right? So what I'm going to do is, I'm actually not in the chain mode. So I'm going to select this chain tool up here. I'll make a chain of 4 atoms and I'll change one of them into a bromine. So I'll select bromine and I'll change that into a bromine. So I got to select this tool. I don't know why it's not working for me. Not going well so far. There we go. Change it into a bromine. So let's say this this bromine atom here undergoes an SN2 reaction. So SN2 reaction. And let's say that it reacts with sodium methane thiolate. So that would be, sorry, I'm having trouble reaching my keyboard with this current setup. So sodium methane thiolate, that's NaSCH3. So it undergoes an SN2 reaction with sodium methane thiolate. So, looks like it's hidden. Where'd it go? Where did it go? Oh, there it is. Okay. So it undergoes this reaction, and what would that reaction look like, and how can we draw it, and how can we draw it efficiently? So what I'm getting at here is there's one thing that I noticed that I didn't cover last time, which is if you select a molecule and you hold down the control key. I don't know what it is on a Mac, but for Windows, it's the control key. I'm holding down control and I click with my mouse and hold it and drag. I can actually drag a copy of the molecule. So I can simply drag the substrate over, and then I can sort of manipulate the individual atoms to indicate what reaction the starting material has undergone. So this SN2 NaSCH3 thing, this is a text. This is a form of text. But let's say I want to draw sodium methane thiolate. So I'm going to go over to draw mode, and so I'll start with a carbon atom. Well, sorry, not draw mode, structure mode, and I'll draw a carbon atom. That'll be the methyl group. And then I'll draw a sulfur atom connected to it. So I'll draw a sulfur atom. I can draw it over here, and then I can simply draw a bond between them, okay? So this is methane thiol, and the reactive component of sodium methane thiolate is the methane thiolate anion. So notice that this is not an anion, this is neutral. So what if I wanted to change this to the methane thiolate anion? Well, I would go all the way down here in the bottom left-hand corner. So there's a menu that pops up that allows you to assign positive, negative charge to atoms. So watch what happens if I have the negative sign selected, and then I click on the sulfur atom. It changes it. It gets rid of the hydrogen, and it changes it into an S-, right? So sodium methane thiolate, really the reactive component is the methane thiolate ion. So I can also draw a reaction arrow. So if I switch over to draw mode, by the way, you can easily toggle between structure mode and draw mode in Chemsketch by pressing the space bar. So if I'm in draw mode, space bar switches it to structure mode. So if I'm in draw mode and I want to draw a reaction arrow indicating that this bromopropane has undergone a reaction, I can select the arrow tool and I can draw the reaction arrow. So there's my reaction arrow. Now, so far I've drawn bromopropane reacting to form bromopropane. But I simply wanted to demonstrate that you can sort of use that control drag move to drag your molecule over and copy it as a template. So basically an SN2 reaction with sodium methane thiolate is going to replace the bromine atom over here with this SCH3 group, this methane thiolate functional group. So how would I do that? Well, I can simply select, I will go back to structure mode, select sulfur. I would change that bromine into sulfur, and then I would just attach a methyl group on it by selecting carbon and dragging that methyl over. So I'll zoom out a little bit. So we've just drawn, I don't know where I am now. Oh, I'm all the way over here. So we have just drawn a reaction scheme that shows this reaction. So that looks a lot cleaner than it would look if you were drawing it freehand, especially if I was drawing it freehand, because my handwriting is terrible. So that's one example of a useful tool that you can use, that control drag feature. You can drag a copy. And not only does this work in Chemsketch, but it also works in a variety of other programs like Microsoft Word, Microsoft Excel, Microsoft PowerPoint. All of those have that control drag feature, so you don't have to copy paste. You can just control and then drag a copy to another part of the document. Very, very useful. It saves a boatload of time. So if we go back into structure mode, actually let's do something else. Let's do something else. So here's an interesting thing up here. If you click on this icon way up here, it has like that chair conformer and a bunch of rectangles. If you click that, that's called the template window, and it'll open up a bunch of templates that you can use, and you can place them in your document. So you can see here there's a bunch of tabs, like this is the lab kit. So I can actually put like an addition funnel in my document. So if I want to, show what equipment I'm using, I can put those things here. If we go back to the template window, we can see that there's some there's a drop-down menu up here. So you can click that, and that'll show you other lab kit templates. There's a Bunsen burner, basic kit, so all your basic pieces of laboratory glassware. So let's look at some other templates too. So here's the DNA RNA kit. So you can draw the sugar phosphate backbones. You can draw the nitrogenous bases of DNA. You can do all these things. You don't have to necessarily draw them out yourself. You can select a template. So let's say I want to represent adenine. So I'll grab adenine and simply click, and that places adenine in the document. So again, these are all sort of time-saving tips. Let's look at some more templates. Let's see what else we have in here. Some of these are actually, excuse me, some of these are actually pretty elaborate. I mean, look at the terpenes. I think there's also, what else? So there's orbitals. So these can be useful if you're wanting to show orbitals. Let's look at some other ones, small ones, large ones. Newman projections. So whenever you're talking about torsional strain, you know, syn, anti, gauche, all the cyclo, or not cyclo, but you know, configurations of butane, for instance, staggered and eclipse and all that stuff. You can use Newman projections. You can place that in your document. Just a bunch of useful stuff. What else? So I talked a lot about structure mode in the last video. Let's talk about draw mode. So I'm in draw mode, and so we showed the text tool. So you can put a block of text in there. You can put in a table. So you can make a table, select the number of rows and columns of that table. So let's say I want a 4 by 3 table, click OK. That'll put a table in there, and I believe you can populate that table with text. You can put text in the table. So there's a lot of things you can do. Personally, if I was to put a table in my document, I'd probably use Microsoft Word for that. But nonetheless, that feature is there. So, by the way, I haven't said this, but if you want to call into the show using Discord, you can do that. There's a link down there in the description. My only ask is that you let me know that you're calling in, because I don't have Discord open or visible on my monitor. So, so let me know in the chat if you are in the Discord. Follow that link, join the call-in show waiting room, and then I can drag you over to the room where I am, and we can talk. You know, we can maybe even walk through this together. You can install it yourself. Installation's really easy. Just Google Chemsketch. It'll be the first link that pops up. Easy download, and it's free. So, I mean, what could be better than that? It's worth way, way more than what you pay for it, which is nice. So, what else can I show you guys? You know, I haven't really had, you know what I should have done is I should have made like a bulleted list and pasted it to my wall up here that shows all the different features that I wanted to discuss. But these are just one example. So what did I show you? I showed you how to change something from neutral to plus or minus. You know what could be fun? At least for me, I don't know about for you guys. But let's see if we can draw an entire mechanism. Let's draw an entire mechanism. We'll do something simple. Let's say we want to show the mechanism for an electrophilic addition to an alkene. Akalesh says, my monitor's broken, so I can only learn. Oh, okay. Well, I mean, I understand that. I hope you get your monitor fixed, or you know, get a new monitor. And it sucks to have a broken monitor. Sorry about that. But anyway, so let's say we want to draw a mechanism showing an electrophilic addition to an alkene. So what I would start with is I would be in structure mode. I can draw a bond. So that gives me the 2 carbons. But of course, if it's an alkene, that means that there's a double bond between them. So if I have the bond tool selected, draw normal, and I click on the bond, then that will convert it to a double bond, right? And let's say I want to draw this a little bit differently. Instead of drawing these as CH2s, let's say I actually want to draw the bonds to the hydrogen. So I just simply drag hydrogen and connect it to the carbons. And let's say that instead of the carbon not being shown, let's say that I want to show the carbon. So in that case, I would select the molecule, right-click, go to Object Properties, and then when it goes under the menu that says Show Carbons, we would select All, and then we would apply that change, and now you can see the carbons are explicitly shown. Okay? So, how does an electrophilic addition to an alkene work? So let's say that we are adding hydrogen bromide, HBr. So I put a hydrogen down there. I'll select bromine, and I'll simply drag it over to the hydrogen. So we have HBr. Okay, so of course the first step of that mechanism is protonation. So the pi bond of the alkene will attack and capture the hydrogen of hydrogen bromide. And of course, in a mechanism, we use curved arrows to show the direction of electron flow. So if I go to draw mode, what I can do is I can select the curve tool over here. They call it an arc. So if I select that, I can actually open various different, I don't know what you would call this, degrees of turn of these curves. So let's say I have a 90-degree, let's start with that. So I'm going to draw it going from the pi bond of the alkene to the hydrogen atom. And let's say, I think in most organic chemistry textbooks, the arrows are shown as red color. So let's say I want to change the color of this to red. What I would do is how would I do that? I can't remember. Object, let's see if I can go to object properties, that'll probably do, oh yeah, there it is. So right now it's shown as black, so I would change it to, wow, it really gives you a lot of options. So I would change it to watermelon, that's a good color. And I would apply it, so now we have it shown as red. So if I click up here, lines and arrows, that should allow me to put an arrowhead on this thing. Let's see. I can't remember. Let's see, tools. I know there's a way. I just can't remember exactly how to do it. By the way, I'm not like an omniscient expert at this thing. I'm a little rusty with it. I'm not used to using this program, to be honest. I use ChemDraw when I'm working, which is way better, but way more expensive. So we'll make do with this, but I'm pretty sure there is a way to put an arrowhead on the end of this, but it's just escaping me right now. Templates, options, can't be it. I want to say it's under tools, arrow style panel. There we go. Arrow style panel. That was it. So if I put an arrowhead on this, there we go. So now we've drawn, we have successfully drawn the pi bond of the alkene capturing the proton. But of course, the electrons that are in the bond between the hydrogen and the bromine, those are going to be pushed over to the bromine. So let's draw that. So I'll select an arc, and I'll drag it over like this. Actually, I don't like that arc. I'm going to use one with a smaller angle here, smaller degree. So I'll simply drag it over to the bromine, and then I'll change it to red. By the way, I'm pretty sure there's a way to change it to red by default, so you don't have to manually change it to watermelon red every time. So I change that to watermelon red, I apply, and then I can open up, I think it was Control-Shift-A was Control-Shift-A. That will open up the arrow. I can give that an arrowhead also, and I can change the dimensions of the arrow head. If I want to change it to being a little more narrow, I can do that. So now I have a narrow arrow or a narrow arrowhead pointing to that bromine. So we've just drawn the first step of the mechanism by which the electrophilic addition of HBr is added to an alkene. So I would draw another arrow, this time a reaction arrow, or the arrow corresponding to this mechanistic step of the reaction. So at this point, the species that will be formed will be a carbocation intermediate. So hopefully, if you're in organic chemistry, this stuff is coming back to you. So I'll select the alkene here. And again, we're going to use that control drag maneuver. So I control, drag, and now I can sort of manipulate this to show it as a carbocation. So first what I would do is I would remove the double bond. This is no longer a double bond. So now it's a single bond. And what I can do is I can choose the, well, first of all, we know that one of these is going to have an extra proton. The other one's going to be without a proton but positively charged. So this is where I can choose the plus sign. So over here in this menu, way down in the bottom left, I'll choose the plus sign, and I'll change one of these carbons to positive. So this is our carbocation intermediate. Now, the likelihood that this particular carbocation intermediate would form is pretty slim because it is a primary carbocation. Let's make it something a little bit more believable. So let's say that these two hydrogens here are actually methyl groups. Okay, so now we have a tertiary carbocation. This is much more likely to form than a primary carbocation for reasons of stability that I won't go into thoroughly here. But not only do we produce this carbocation, but we also produce a bromide ion. So I'll put a bromine there. It immediately gets populated with a hydrogen to make it neutral, but we're going to change it to a bromide, which is negative. So now it's bromide ion. And so what's the second step of this mechanism? So let's see if I can select all. I'll push this over here. Can you guys see that all right? You know, I could change the properties to make the thickness of the bonds larger, to make the bonds thicker. But let me know. So far, there's only been one participant in the chat. If we're going to get a discussion going, let's get a discussion going. You know, type your thoughts in the chat, too, if you're in here. Call in via Discord. That's an even better alternative. So let's say, okay, so I'm going to draw another reaction arrow so I can simply control drag this reaction arrow to produce a second arrow. And by the way, it's not necessarily a reaction, it's a mechanism step, but I'm just calling it a reaction arrow because I can't think of a better term. So now what I can do is I can drag, or I can do the control drag, drag a copy of my carbocation intermediate. I can drag that to over here. And so the second step of the mechanism is the nucleophilic addition part, where the bromide will attach on to the positively charged carbon of our carbocation intermediate. So I'm going to draw another arrow. So maybe I can copy this arrow over here, and then I can rotate it. So I'll rotate it around, and maybe I can resize it. So instead of drawing a brand new arrow, I can just copy an arrow and manipulate it. See how well this works. Let's see if I can resize, shrink it down, and make sure it's pointing to the right carbon atom. So let me rotate it again. By the way, if this content is useful to you, please let me know. If it's not, also please let me know. So there it is. So now you have the bromine glomming on to that positively charged carbon of our carbocation intermediate, and we can reflect that addition in our end product by simply taking a bromine atom and connecting it to this carbon. So there you go. We have just drawn an entire mechanism using nothing but Chemsketch. And you can clean these structures up and make them look much nicer. So like, let's say I select this product here, and I click this button way up here, this red and white icon. That's to clean the structure. So now it looks a little bit cleaner. It looks better. And let's say I wanted to remove all of these hydrogens, or if I wanted to choose not to show them, just have implicit hydrogens, well, I would select the molecule, right-click, go to Object Properties, and then when it says there should be an option to show or hide the hydrogens, but I'm kind of lost on it right now, to be honest. I don't know where it is. I thought it was here. Maybe if I go to Atom? No. There's a way to turn that off. It's just kind of escaping me right now. But anyway, you get the idea. So you can use structure mode to draw your structures. You can go into draw mode to draw your arrows, your curved arrows that show the direction of electron flow. And you can make a nice looking mechanism like the mechanism of the electrophilic addition of HBr that we just saw. So let me check to see if there's anybody actually in here. Make sure I'm not talking to an empty room. Let's see. Where do I even go to see that? Oh, okay. So I guess there's three people in here. Well, I hope all three of you are enjoying it. Not stellar viewership, gonna be honest, but to the three of you who are here, I hope you find this valuable. I really, really do. So, well, what else can I show you about Chemsketch? Let me think here. Let's see. You can draw reaction arrows. You know, that might be about it. At least for what I use it for. You know, go watch part 1. There's a lot of information in there. If you didn't watch part 1, watch part 1. There's a lot of information in there. But my point that I want to get across here is that this is a very, very useful tool. It is absolutely free. And if you are an organic chemistry student, I think it is foolish not to download it. It'll help you. And, you know, there do exist other molecule editor softwares out there. The only ones that I'm familiar with are Chemsketch and ChemDraw. But there are others as well. I haven't explored them because Chemsketch and ChemDraw do more than enough for me. But, you know, there are other ones, and I'm pretty sure there are other free ones. So that's an option as well. Search for another one. I'm just going to play with some of these templates here. So I'll go back to the template window. So let's see, I'll just erase all of this and I'll go to the template window. Now I touched on this earlier, but I didn't explore all of the templates. So that's something that we can take a look at. So if we go to our carbohydrates, for instance, so this shows like Fisher projections of the straight chain form of all these different carbohydrates. Stereochemical, you see wedges and dashed lines. Let's see, Fisher stereo. I thought it was actually going to show the ring form too, like the pyranoses and the hexoses and stuff like that, or glucopyranose. It's been a while since I don't remember all the biochemistry jargon. Graphical labels. Let's see what's in here. So I guess this means like an explosion or something. You can put an explosion in our document. Go back to the template window and let's see, what else do we have? Oh, that only has one page. Let's go to steroids. So a bunch of different steroids. So yeah, it would take you a long time to draw these things, but luckily there are templates that exist that you can just use. Click on it, click on the document, and it'll automatically put it in your document. Let's see, what else? What other templates can we explore? Let's see. We already looked at the lab kit. So aromatics, you can draw a benzene ring. There's actually other ways to draw benzene rings too. You don't have to go through that song and dance. Like on the toolbar on the right, there's many different shapes. So let's say I want to draw, you know, like a fused ring or something. So I would draw the 6-membered ring. And I can select 5-membered ring and draw that over here. So you can see kind of by the way you're hovering over the molecule, how you can connect them. So you can connect them together like this, or you can fuse them together like that. So now we have a bicyclic structure here that we're looking at. What would the name of that be, by the way? Let's see. Let's test our organic chemistry knowledge by trying to name this molecule. Anybody in the chat, take a stab at trying to name this molecule here. See if you can name it. And we'll see if my answer matches your answer. So we've got a 6-membered ring fused to a 5-membered ring. What would this be called? Nobody? Nobody wants to take a stab at this? All right, well, I guess I will go ahead and name it. Now, I think this would probably be easier to do freehand. So what I'm going to do is I'm going to copy this, and I'm going to paste it into another software. So what I'm using here is Microsoft OneNote. So Ellie says, "What are you doing? I just came here." So the primary intention of this stream and part 1 that I did the other day is to show you guys a very, very useful piece of software that is absolutely free that goes by the name of ACD Chemsketch. Search Chemsketch in a search engine. It'll be the first thing that pops up. You can download it really easily. You can make nice, clean, polished looking structures, and it'll actually help improve your understanding of organic chemistry. I firmly believe that. So I just copied the that image there, that structure, that fused ring, so I can paste it into this. It's really, really small. Let me zoom in. I don't know why it's so small. Let's see if I can try it again and maybe resize it. So let's select it and then resize it, make it bigger. There we go. Now we can see our structure. There it is. Ellie says, thanks for the explanation. I will try to keep up. Yeah, and feel free to, if you're on a computer, I would suggest downloading the software right now. You can follow along with me. But currently, this isn't Chemsketch that I have on the board right now. This is OneNote. And I just realized something. Let's see. Hang on. Let me open up my streaming software and make sure. Yeah, okay. It still looks good. I thought it looked weird for a second, but it looks fine. So I'm going to draw this freehand, or I'm going to name it. So this is just kind of a side departure. We're talking about nomenclature of bicyclic compounds here. First of all, how many carbons are in this? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons. And there are no double bonds or triple bonds, so we know that it's an alkane. It's a bicyclic alkane. So given that there are 9 carbons and it's an alkane, we're going to call it something nonane, right? Remember, nona is the prefix for 9. So this is going to be some form of nonane, right? We know it's going to be a bicyclic compound, bicyclic. And we know that because we know that it's 2 rings, because we would have to break 2 bonds to make this an acyclic compound with no rings at all. So it's going to be not bicyclic, but bicyclo. So it's going to be bicyclo. And then what we're going to do is, in brackets, we are going to show all of the bridges and how many carbons those bridges are. And we're going to separate them by periods. So I'll place 2 periods in here because we have 3 bridges. We have this bridge right here. So these are our bridgehead carbons right here. So we have how many bridges? We have this bridge right here. We have this bridge that goes around this way. And we have this bridge that goes around this way, for a total of 3 bridges. And so let's look at how many carbons are in each bridge. We have a 1, 2, 3, 4 carbon bridge. So for the first one, I'll draw a 4, or write 4. For the second one, we have a 1, 2, 3 carbon bridge. And so for that number in between these periods, put a number 3. And then we also have a 0 carbon bridge. So that 0 has to go in there too, indicating that our bridgehead carbons are directly bonded to one another. So this would be bicyclo 430 nonane, right? And again, the way that I was able to draw this nice clean structure, copy it and paste it into my OneNote notebook, is by using Chemsketch. So let's go back to Chemsketch. So I'll minimize OneNote. So I'm in Chemsketch. So that's how I drew the structure. I copied it and pasted it into another piece of software with which I was able to draw freehand. Now, I don't know if you can draw freehand on Chemsketch. I don't think you can. That'd be cool if you could. And by the way, I'm using this graphics tablet here. This is a Wacom tablet. I think it's about $50 on Amazon. It comes with a pen. You can use the pen and the tablet to draw freehand on a computer screen. I really, really like it. It's what I use. It's what I've used for a very long time doing videos where I draw freehand. So, all right. Let's see how y'all are doing in the chat. Any thoughts? Thoughts, comments, concerns, criticisms, what have yous? Now is the time to drop them in the chat. All right, so what else? What else can I show you? So we we just named that molecule the old-fashioned way, right? And again, this is something that I showed in part one, but we just named the molecule the old-fashioned way. But we could actually name this molecule much more easily by using this tool up here. So if you see this, it says, should be a message that pops up. Actually, let me go back. I'm in structure mode. I don't know why this is not working. So select that, and then this tool up here, yeah, there it is. It says generate name for structure. So if I click that, it shows a name. Now it's actually naming it differently. Octahydro 1H indene. Okay, so apparently some of these bicyclic compounds have names that are very, very common that are accepted by the IUPAC, International Union of Pure and Applied Chemistry. But trust me, that name that we saw earlier is also a valid IUPAC name, bicyclo 430 nonane. All right, so what else can we talk about? So we've talked about a lot. I showed you that very handy, useful control drag technique where you hold the control key, you can drag a copy. I'll show you once again. So I have that molecule selected. I'm holding down the control key. I drag over, and I just created a copy of my molecule. We went through step by step the entire process by which we can show a mechanism of a chemical reaction. Our example was a electrophilic addition to an alkene. Very good stuff. And then what else did we do? We explored the template window. We showed how to make text, how to make tables in draw mode. You can also make shapes, boxes. So I've chosen a rounded rectangle, and can make more rectangles if I want. So there's just so many possibilities with this software. You can really, in a way, you can kind of do anything you want with it. You can show anything you want, and it'll help you tremendously, especially if you want to make some nice, clean, polished, typed up lab reports. So, all right, guys, I think that's pretty much, I mean, how long have I been streaming here? I don't know. How long has this stream gone on? It's not saying. Oh, yeah, 37 minutes. So I think that about does it. I mean, I'm sure there's more features, but they're just not coming to mind right now. But I hope this has been useful. Again, there was a lot of information in part one. So I highly suggest you check that out. It's just very useful. I mean, this helped. What I'm doing is I'm trying to show you stuff that I wish I would have been exposed to sooner. Because this piece of software helped me out so much. And it wasn't until like midway through studying chemistry that I found this. I didn't think that something like this would be available for free until I looked it up. So you'd be surprised how much very useful free software is out there. And yeah, there's a lot of bullshit too, where the free version of the software doesn't do anything, or it shows some watermark that you have to pay for the premium version to remove the watermark and all this. But this software doesn't really have that many restrictions. Yes, it does have a paid version with more features, but the free version offers quite a bit. So there you go. Just wanted to show you Chemsketch. And if there's any other topics that you'd like to see discussed on this channel in the future, please let me know. I can't guarantee that I'll actually, I don't even know what I'm doing tomorrow. So I can't promise that I'm going to stream again soon or even at all. I'm simply doing this because I'm bored, and I just think it's something that's useful and cool and valuable to talk about. I am not being paid by ACD Labs, which is the company that made the software. They're not paying me. There's no promo code. There's nothing like that. So I'm just showing you this because it's cool and it's useful. So, all right, guys. If that's it, then I think I'm going to get going. But I hope you have a great weekend. It's interesting because I've never streamed on a Saturday morning. This Saturday morning time slot is something that I've never explored before. But, yeah. So that's it. Bye, everybody. Take care.